Alright guys, welcome to another video, and in this video we will be looking at data visualization. Right. In the previous videos we've seen from NumPy all the way to pandas, we've seen how to handle data. Now I want to see how to present our data in graphical representation, how to communicate our data to non-technical people or audience that we might have. As they say, a picture is worth 1,000 words. So without further ado, let's jump into it. Okay, I'll just zoom in. Okay, I think this is good. So visualization is how we communicate our findings and explore intuitively. And we'll be covering three core libraries, three major ones. Matplotlib, which is more like a foundation of visualization using Python. Then we look at Seaborn, which is built on top of Python, just like we have pandas built on top of NumPy. And then for more interactivity, right, considering that some of you, depends, for those of you who have a data analysis background, right, you're probably used to interactive charts. So we will not stop at static charts only, where we just have charts that we cannot talk to, we cannot interact with, right? So because of that, we'll also be taking a look at Plotly for interactive charts. And for Plotly, you can build a full dashboard with it. But let's just jump into it one after the other. Okay, so we'll be starting with Matplotlib. Now for matplotlib, it is of course widely used in Python, and it gives you a nice chart. The only thing with matplotlib is more of a single, no more. For the first method we'll be exploring, which is more like the functional method, using the PLT, right? It gives us less control, more of a single figure or single canvas kind of thing. All right, you probably don't understand what I'm talking about. The first thing, let's work with some data sets. So I will just import NumPy. I'll import NumPy as NP and import pandas as PD. Import pandas as PD. In this case, I want to create a data set, a synthetic data set that we will work with. Okay, so let's create a data set that will work with. Let me zoom in a bit more. Okay, I think it's better this way. Now, that has loaded. So let's just do some custom data sets. Now, there's something I will have to do first, and it is to set seed. Set seed. Now, why are we setting seed? To get consistent, into bracket, the same random values, because we'll be using some random values, we'll be doing some random generation. So for us to get the same thing, because if we leave it at random only, I'm just doing, for example, .rand.this, you will be getting different results, because of course it is meant to be random. But when we set a seed, regardless of how many times I re-execute my code, we will get exactly the same thing. Exactly the same thing. So that's why we're doing this. So we just set a seed. I'll say random np, and we can get that from np. That's numpy. I'll say random.seed. All right. So we can pass in a value. Any value I pass is what you should also pass, so that you can have the same experience as I do. Okay. So we can just put, let's say, 100 or 101 in there. Now that we've set the seed, we want to generate. So let's generate. So let's generate. Let's say about just weird number, 4050 records. I know it sounds like a lot, and it should be this time. We have worked on different data sets. but mostly sales direction. So let's say records for factory shifts. No, in factory where the work is like 24 hours. So we can say this sheet is for every 4 hours. Okay, yeah, I think that should work. So once we want date, of course, so we can say date range, and for date range we can use pd dot date range. Okay, now we can set a start date. If you read down just a little bit, you can see you can set a start date, you can set an end date. So it can help you get date, right? Help you get date. So you can say start equals, let's say 2026. Should we use 2026 for that much record? Let's just put 2022 or 2021. All right. Let's say 1st of January, of course. The factory will start at the beginning. Then we'll say periods. This is where we're now passing the number of data sets we want, or the number of values we want to generate. So we can also pass in the frequency. Now, if you wonder, you see, like I have everything in my head now, right? You have them there. You can see in the documentation string. All you have to do is just do a little read, and then you see what it does for you. And most times too, there's always an example down here. Okay, so there is no magic going on here. Most times, as you can see, if you look at an example, you have a start date, you have an end date, and then you can pass in whatever it is you want, right? So you always see examples inside the documentation string. So this gives you the flexibility to be able to explore on your own as well. So since we have specified that it's for every 4 hours, so just put it. We are not putting any end date in this particular data set. So what else do we want to do? So let's simulate the factory operation, right? Simulate factory operations. Is it factory operation? Factory operations or factory metrics? All right. So let me have a variable assembly time. Then we'll do mp dot random dot normal. Right, I think there should be a normal. Okay, yeah, see it right there. So mp dot random dot normal. Then we'll put the lock. We'll say that will be 45. Like I said, you can just read through the documentation string to be able to explore or see what all of this thing means in full. But don't worry, for now the only thing is I want to generate a data set, so you can just type along with me. But if you're that curious, you can read the documentation string in there, and then we'll say size 4050 as usual. So just so you understand, this is more like the time to assemble the chassis. Let me just add it as a comment. So let's just say time to assemble a vehicle chassis. We're just doing something about this time. So then we can say so let's say we want to put in a sensor, because of course there will be sensor. So we'll say sensor temp in Celsius. So yeah, that's how to spell Celsius, right? So we can say the assembly time in minutes multiplied by what number now? Okay, multiply by, let's just do 1.8 plus np.random. Now remember that we have set we already set the seed to be 101. So any value I'm getting is exactly what you get. So you can always do that once we inspect to cross check that we're having the same thing. Okay, so log 10 scale 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 3, what else, size, of course, size 4050. Okay, so this will be like temp correlated temperature correlated with the workload. Okay, like I said, you don't have to overthink what I'm doing. When the data set comes out, that is what you want to work with. But if you're curious, you need to have an idea of maybe what. Now, as a data analyst, right, or as a data scientist, you don't need to know about all fields. When you need to work on a particular field, is that you have domain experts to work with, you have business analysts to work with, and all of that. Okay, so in this case, we just want to create a data set. But analysis, you already have the foundation of carrying out analysis, so it still remains, let me say, the same, because the foundation, so it's still the same. So we're just trying to create a data set. So let's say robotic station, and this will be np.random choice. Yeah, we have choice. So we want to like do a group of, what's it called now? We want to have a group of, I think I can just pass it as a list, and then I split it, right? Yeah, that's always my choice. Okay, I will just type anyway. Let's say welding station A. Let's say paint shop B. Battery, we'll just use some random names. Battery mount C. And let's say, yeah, quality control, automation, process, factory. So let's have quality control. And that will be D. So we know how choice work already. If you didn't see the what's it called now, the module, the Python module video, I think I'll leave link to it in the description below, or it should pop up somewhere here. But if you want to just see this first and then you then check it out later, you have the link in the description below. But if you want to check it out now, the link should be somewhere at the top right there. Okay, so it just basically picks any of these for, we have 4050 records, so it just randomly assigns those records to the data. So, and of course we have to pass in the size. So I'll come here and say the size. Why is that not coming up? 4050 again, just pass that in. So what other variable do we want to have? We can say micro downtimes. I mean, we always have downtime. Oh, we might have downtime. Don't let me say we always have downtime. Random. In this case, let's use Poisson. Yep. Then this will be 1.5. Size as well. That will be 4050. Can just call this minor line micro stoppage, whatever it is. Micro stoppages. Which one be correct? I think stoppage should be correct. Engineering or mechanical, if we have a mechanical viewer, can just put which will be more correct in the comment section. Okay, so we want to create an actual factory data set. So just say df factory. Should we do it inside here? Okay, let's use that for more like a prepping stage. So we have all our variables declared. Then inside here, I'll just put df.factory. So Control O, create the full data sets here. All right. So just do pd.data frame as usual. Then open. Then we'll pass in the dictionary of our variables. So timestamp. Timestamp will be our date range. Our date range variable, you remember them. Why is it not coming up? This thing should disappear. Okay, so let me execute the one at the top so that we can have the autocomplete, right? Let's run this. Okay, all done. It's saying 4 hours. Please use small letter h. So it wants me to use small letter h, but I'll just ignore that. So if you are yet to execute yours, you can use the lowercase h instead. There are a lot of new changes. Of course, it's a programming language. There's always updates to make things better and all of that. So yeah, that makes sense. So data range, that's what I typed. I think that was why it wasn't coming up earlier. So the next thing is station, and that will be robotic station. Next is cycle time in minutes, right? Cycle time in minutes. But then for the ease of calling this variable, okay, let's just continue. Since they always go in quotes anyway, so we can just do np.random, np.random, no, dot round, I mean, np.round. Then we'll pass in our assembly time. We'll say 2. We want it to be in 2 decimal place, right? We don't want it everywhere. Then we want to pass in the sensor temperature in degrees Celsius. Just put Celsius. So that will be our np.round as well. So we want np.round sensor time in Celsius. We want that to be 1 decimal place. And finally, micro down times, and that will be micro down times counts. Okay, so with this now we can now in this case we want to turn it into, let's just check it from here, df factory. We want to make it a csv file, right? We want to make it a csv file so it becomes a data set that can be reused anytime. So let's run that. Nice. Our data set is coming out so far. Oh, okay, this is cool. So let's convert that to a csv file. So say df factory. Since it's just a single sheet, we don't need to put it to Excel, so we can just convert it to a single say to CSV. Then we'll pass in the name, what we want to call it. So you can say TFA autos factory logs dot CSV. Then we'll say index equals false. All right. So say index equals false. What else do we want to do? I think we should then print data set created successfully. Successfully. All right, let's check that out. True. Okay, it says data sets created successfully. So let's check. All right, you can see we have our data set here. And of course, this is only temporarily available. To download it, you can just click on download so that you can actually have it on your PC or on your drive or on whatever device you're using it, and you can see it is downloaded. If I open this in Excel, you'll see all the data sets in there. Okay, so I'll just copy the file path. Okay, copy the file path and then read the CSV version of it, because the idea is to use the CSV version of it. So we can just say df, oops, no text. So we can just say df equals to pd dot read CSV. Then we'll pass in the name, just like that. Then we'll do df dot add, right? We'll actually see the same thing I've seen before. So you can see this is what we have, and it's just exactly what we've seen here. So like I said, if you check yours, you should have the same value as I do. You should have the same value as I do. Okay, so if we check the shape, let's inspect this data quickly. df.shape, just to confirm everything is correct. You can see we have 5 columns, 4050 rows, so it's row by column. Why am I picking a text? Sorry. So df.describe, and then remember we can pass include all, so that it includes the numerical or the qualitative part as well, though it will have some none, no doubt. So we can see quick thing about our data. Let me just take it out. I think we'll go to the numerical version. So we can see a little bit about our data. So we have 4055. The mean, the average, you can see we already got some quick value about the cycle time, sensor temperature, micro downtimes, and all. So, why am I picking texts? All right. So let's do df.info. Sorry, let me start. df.info, so we can see that we don't have any missing value in at any point. So we have a string, or an object rather, an object. So if we want this as a date, we have to convert it to say pd to date time. Okay, it's currently an object. This as well, can grab our string from there. So this is what we have, and yeah, I think we can now jump into what we want to do now that we've created our data sets. So again, let's just bring in the df.add right here. Okay, then execute that. Okay, so just before we go far, as much as I remember saying, okay, if you want to understand some of the things I was using in creating the data set, that you should read the documentation string. However, it is important, where are we again? it is important to understand the variables we are working with, at least, because when we analyze the data, we should have an idea of what individual variable means. So for the date or the timestamp, obviously that is simple. It's just a timeline for our data set, right? And it starts at 1st of January. So let's do df.tail. So let's see where it ended. Let's see where it ended. Oh, okay. So it got all the way to 2023. That's 11th 2023, right? So it's just meant to be a 4 hours difference, right? There's a 4 hour interval for each. If you pay attention, you see that it's all 4 hours interval, right? It's good you understand your data. All right. So the next thing, which is our station is basically where the specific location in the factory where the log was recorded, right? That's where the log was recorded. That's what our station is. And the next thing we have is our circle per minute. And if we go back here, where do we have the circle per minute? You can see we used our assembly time. And what does this mean, right? What does this mean? In simple English, it's just the time taken to assemble a vehicle chassis. Do not forget that we created a random data set or a synthetic data set for the a factory, right? So where work goes on and every time, and it's an automobile factory. Oh, error. So it is just the time taken to in minutes. Now don't forget the unit is in minutes. The time taken in minutes to assemble a vehicle chassis, and it uses the normal distribution, normal Gaussian distribution. That's topic for another day. Maybe mention in statistics later or something. What else should you know? Well, the idea is that most times it takes around 45 minutes, but due to minor error and delay, some record will go above 45 minutes, things like that. So it's usually that's the idea for the circle time minutes. It's important that you follow the explanation so that the analysis you want to do will make sense to you. Okay, that's why I'm taking time as well. I didn't just assume you understand them, and I'm taking time to explain what each column mean. Okay, or means, I mean. So the next one is the sensor temperature, and it's just the operating temperature of the machine or machinery during the shift. Okay, it is the operation of the machinery during the shift. Very important you understand. Now the idea is if a chassis takes longer to assemble, the machinery or machine has probably worked harder, so causing causing the temperature to rise. So what the code does is that it multiplies. If we go back up here, so it multiplies the assemble time by 1.8, right? And then you had a base temperature of 10 degrees Celsius with, let's just say, a variation of 3 degree, which is the scale. And that's why we have this here, right? So the base temperature is 10 degree. The slight variation that we are hoping happens is just 3 degree Celsius. And of course, our size is our data set. So is there any other thing we have not mentioned? Okay, downtime. Well, I mean, downtime is what it is. It's just the number of minor or maybe number of stop time, or stoppage, glitches, anything at all that causes the machine to stop for a while during the 4 hour window or 4 hour period, right? That is what this is. And we're using the Poisson distribution. Of course, we're not really going into the Poisson distribution and all of that. So we are using lambda of 1.5. I guess was it 1.5 that we used? Yeah, we're using lambda value of 1.5, which simply means on average, a particular station, whether the robotic or the battery, is that robotic? Okay, robotic is very new. Whether the welding, the paint shop, on average, we're saying the station experiences, let's say, 1.5 mini stoppage per shift. So that's the idea of the lambda size of 1.5. So most shifts will have 0, some will have 1 or 2, right? But sometimes you might experience just higher spike like that in the in the in the downtime. So you can say we have 3. So yes, that is all to know about our data. Now let's get into the analysis or visualization. Rather, let's get into the visualization. Okay, so the first thing we probably want to do is to import matplotlib. So say import matplotlib. Okay, so it's showing me the auto completion dot pyplot at so at whatever it is, matplotlib.pyplot as plt. Yeah, so then the next thing is we want to, now you see I left a comment here so that when I get it I just remember that there's something else I'm supposed to do here. So tell the Jupyter to display inline. Now we want if we want to avoid plt dot show, which is a way to display charts, right? If we want to avoid writing this every time, I'll still show you, still write it. We can use something we'll do a percentage sign, then we'll say matplotlib, then we'll say inline. So we're saying it should display it under the cell. So if I run this, everything is fine. So the first thing we want to look at is a bar or a line chart. So we want to look at the daily average temperature trend. That's the first thing we want to look at. So we'll prepare a small data set. We'll prepare not a small data set, a timeline, just a 30-day timeline, so that we can visualize this, right? But before we jump into it, we have 2 ways of using using matplotlib: the plt and the axis. Now for plt, we are just working with, let's say, single plane chart one at a time. But for the ax or the axis, we want to use different plots, more like a matrix where we want to have subplots. We can have one here, then another one beside it, then another one down here, then another one in a single canvas, in a single image or picture, right? So but first we'll start with the easiest one, or the basic one, the fundamental one, before we now move to the other one. So we'll just repeat the same thing we do with this with the subplot, so you can have a good understanding of it. So let's just say daily df equals to what is our data? Okay, I think it's just df, right? It's just df, though it's the same thing as factory df. Well, we can say set index here. So that I'm looking for timestamp, so we don't start seeing generic stuff. I'll do a resampling. Then we'll just put capital D there. Then we'll do a mean. Of course, we want it to be numbers, so we'll say numeric only. Then we'll say true. What else do we want to do? Reset index. By now, from the knowledge of pandas, all of this should not be strange to you. So let's check the head. Let's see about 20. Okay, let's see about 20 of it. Now none of these or most of these should not be strange to you, right? For example, while we have a long condition, we just use the dots method to chain commands like that, so it works just fine. So let's check that. Okay, what did I miss? I'm missing something. So it's saying daily, okay, only valid with daytime index, delta index, but got an of index. Okay, so one way I would say it is to debug error fast, right, apart from whatever you're seeing, is check the type of error first. We have different types of error. We covered that in the error handling, error handling session. If you have not seen the error handling session, I'll leave the link to it in the description below, or it might pop up at the top somewhere here. So since it's a type error and it's saying, oh, okay, datetime index, delta index, but you got an instance of index. Remember, when we checked our data set, this is an object. So we have to convert this. I think I mentioned it when we we're looking at this. Convert this to a datetime object. So how do we do that? We can just say, just right before here, say df dot timestamp, right? So df timestamp single, then say pd dot to datetime, then we'll pass in df, nope, not this, timestamp, timestamp, timestamp. All right, so we should not have any problem anymore. Okay, and you can see that is gone, but it's supposed to display for us, but it is not. Oh, okay. We're saving it inside this variable. I just noticed that now. So let's make it about 30 then. Let's do 30 since we want to do a 30-day timeline. So we'll make it 30. I think let me just put the conversion at the top. Let me take that out. Oh my god. I just hope this powerback sound is not really messing things up for me. Alright, so we converted here, and then we want to check daily df. Let's just check daily df to see what it looks like. Okay, nice. You can see what we have now. We have been able to get these parts just for 30 days, right? We only got for 30 days just to demonstrate the line chart. So consider this as creating a subset of our data, right? We created the subset of our own data set. That's all there is to this. Now, one thing we might always want to do first is to set a size. So we can do plt dot. As usual, once you use your dot notation, you see different options of what you can use. So we'll just go to figure, figure. All right there. I want to set the shape, right? I want to set how big, or the dimension. Let me use the dimension. So we'll say fixed size, and we'll pass it in as a tuple. We'll say 8 by 4. We're only setting the ground, we're setting the size of the data. Now, to do any visualization with pyplot, with matplotlib, the key thing you should remember is plt. We imported it as plt dot the chart name. That is all. So for a line chart, it uses the word plot. Now, for you to know all of this, you can always go to the documentation. So matplotlib documentation. All right, so you can always go to the documentation section, and if you go there, you'll see all the charts in there, right? You see all the charts, you see everything you need to know about matplotlib. So let's cancel that and come back here. So dot plot is how we do for a line chart, and then we can pass in our data set, right? So we'll say, now for plot, we need to pass in some variables, right? The x-axis, the y-axis, and the rest. So for our x-axis, we'll say daily. It is positional, right? Remember positional argument. Okay. So daily df dot timestamp. So that will be on the x-axis. Why is it showing me to cut? Then again, Though we can extract all of these in single variables and pass them in, but it's better this way. And then this guy will be sensor. Sensor. Now we can pass in color as either an hexadecimal code, that's E3EF and whatever, or we can just pass in an actual color. Let's say, for example, orange. Okay. Now we have a marker style. That's all the parts where there's a change. So we can set it to be, and say marker is this symbol, this O symbol. So that's that about the plot itself. So let's execute this. Now, because we have done matplotlib inline, right, we don't need to do plt.show again. So you can see for every point in time, you can see the dots, you can see the dots, you can see the dots, you can see everything. This is a 30-day timeline. Of course, this axis is not looking good because of the way it is. We could have just extracted maybe the date time or the month name, right? But if we extract the month name, they're all the same month, so it's just a 30-day thing. Now, what other cost? Now, this currently is not making any meaning. No title, nothing. How can we add title to this? We can just go back in here and edit it. To add a title, we just say plt dot title. Then for title, we can say this is the daily average sensor temperature. Daily average sensor temperature. Now we can also add an x-axis. So say plt dot x label, which is the x-axis title. Then we can say that is date. And then plt again dot y label. Yeah, you probably guessed that already. And that will be temperature, 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 right? Yeah, I think it's like this. It looks weird, but I'll just leave it that way. I believe I'm correct. So what else? If we want grid, let's say plt dot grid. Then we'll pass in true. What else do we want? Let's do this first and see what it looks like. You can see the grid is looking horrible. Not so horrible, just that it's too thick. So I mean, the grids are not bad. We can easily trace with them, but it's too thick, right? So to make this look better, we can go back here and pass in other variables. If we want to know the variables we can pass in, and come here, and you can see what do we have? Docstring is not showing up properly, but we can pass in color. You can say color should be gray. We can pass in line width 0.5. You can pass in alpha, which is alpha is basically the transparency. Alpha is the transparency as 0.5. Okay, I think comma is in there. That controls the transparency, and I'm passing line style. Is it line style? Right, line styles. And then we have it as hyphen, like a dotted line. I'll put that in quotes. Okay, so let's run that again. Okay, so it seems like it's got, ooh. Okay, so value error. I think it's probably my lines. Yeah, exactly. One of the things I passed is not correct. So one of the parameters, okay, should be line style. Is this guy right here. Come out. It should be single. Come out of there. So it should be singular, and this should not be a, yeah, it should be like this. All right. where is it? Okay. Okay, so you can see we have it as dotted lines, and the line width the line width seems too much. Let's do 0.1. Okay, so it's still showing, right? It's still showing, but we can just make it 0.2. Let's see what it looks like. So you can keep, aha, all right, I think this is better. So we can trace down and trace up to a particular date and a particular time or temperature, right? So you can see what it looks like. You can see we now have it labeled. Temperature is a daily sensor temperature, and this is looking really, really good. This is looking really, really good. What else can we add? We can add xtick, plt.xtick, just to show you some other variables we can add. We can say rotation equals let's say 30 degrees. Now if you look down, let's run that first so you see what I'm doing. You can see, so our dates that was not showing properly, right, is now showing properly, because before it was really, 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 really messed up, right? Before it was really, really, really messed up, but we can now see it's proper. But of course this is truncated. You can see 0105, then it keeps jumping that way. And this also this is a better way because we have many values, so it truncates them for us. But we can trace down with the line, since we know it's a daily thing, so we can trace down with the line to see what that looks like. And just in case, just in case you want to save this, you have to do plt.save fig, like you want to really download this. So you can give this a name. Let's say line chart of daily DAST, DAST, and then you can what other variable can you pass in? Okay, you can pass in the DPI. Let's say DPI is 300, and then you can say B, is it B box inches, right? I think it's, yeah, B box inches, and then you can just say tights, tights. Okay, that should be a string. Okay, so if you want to save it, so you can just run this code and then it's gonna save. Let's run it again for the last time. Okay, so let's check. So you can see we already have it, and we can download to our file. So download, good. All right, so I believe you've learned so much in just the introduction, or not necessarily the introduction, with doing this alone. So now you know how all of this work, and it's easy for you to do anything you want to. If you want another chart, you just change this to whatever it is. For example, bar, so you get a bar plot or a bar chart from there. So let's look at the bar chart. Let's say the total incidents by count station, right? Now one thing is true. Let's do our df again, dot add by station. You can see that stations are repeated. See quality D, quality D, quality D. So if we do something like this, so let me take this out and say for our bar chart, we want to do plt dot figure. I think I'll just copy what I have here. Okay, let me just write on. We're almost there. Plt figure. Then we'll put in our fig size. And we'll say this time 7x4, which is a tuple. Close the bracket. Want to do plt dot bar. Then we'll pass in the station. That's df station, df station, and then comma. Now pass in df station downtime, or I said the station micro downtimes. It should come up. Oh, that's a long thing to type. Okay, micro downtime. And then let's say color. Color. We have color. Yep, we do have color. Why is it not coming up though? So for color, we want to pass in. Let's say steel blue. Okay. So let's execute this first. Now you can see it's taking long already. It's taking long, and okay. So this looks good for us. We have this, we have this, we have this. Now one better way to handle this instead, right? If this were a pie chart, it might not have come out well. And you can see it says container object of 4050 artists. Now, what should we have done? The best thing we should have done is group the data first. Okay, because we know it's supposed to be grouped. So we can call it station downtime. Then we'll say df dots group by. Then we'll pass in is this station? Yeah, station is the name. Station. Then in square bracket, what we want to aggregate by, which is basically micro come up. I'll just copy it from here, micro downtimes. So which is micro downtimes, and then I'll do a sum, right? Because it's number, and I'll do a sum. And of course, reset index. So we don't have those funny things showing up. Good. So now this is what will now pass into this place, right? And I'll pass this into this place instead of the entire data frame that we passed in. So I can do not forget that we have station. Let's print this out. Let me print this out for you to see. X code station downtime. No, station downtime. So let's see what that looks like. You can see this is what we have. So we have station, we have micro downtime, we have the two columns in there. So we can just take this out and say station downtime instead of the entire data frame that we're passing. So we have a group version which is smaller in size. So let's rerun that, and you can see now that it was faster and it contains 4, not 4050 plotting individual ones together. If these were bigger, you would have seen that it's more like a line thing that we had earlier, and you can see the way it is now. It is more this is the professional way it should be. Okay, this is the professional way it should be. So we can see that station D, right? I'll just use station D. Control quality has highest downtime, right? It has the highest downtime. Of course, remember we could sort values in here, right? We can do dots. I think I should put that before dots sort values. Oops. Okay, let's put another dot. Can do dot sum, right? I think everything should work like this. Do I have to break it from here? I think if I break it from here and then I indent it somehow. Okay, let me take it back up. Sorry for the breaking transmission. So sort values by, then I'll say by the the sort by the micro downtimes, right? So in this case, we don't need to pass in the by because you can see it's already showing up. We're grouping, so we can just say ascending. Ascending is false. We want it to be top to bottom. Ascending, then we'll say false. All right. So ascending is false. If we run that again, Okay, so this is what we have now, and if we print this out again, good, we now have it sorted this way because that is what we passed in, so it looks much nicer right there. So we can add title and say plt dot title. So we'll be doing this fast now since you now know. So total, what's the title I gave it? Total incident. Okay, total incident. Or let's say total, let's use another English. Total incident count by station. There's nothing. Total incident count. Incident count. Or it can be line stoppages, right? Per station, because something there was a downtime, line stop working, or whatever it is, per station. Okay, and then we can say PLT. We can obviously we know what the X label is. That's more obvious, right? These are the station. So, and since we're adding title per station, incident count, we can just put in the values. We can always put in values for both of them. So just do for Y label only in this case. Y label, and then we'll say downtime events count. Downtime events count. So let's do that. All right, this now looks better and now makes more sense. All right, so we'll be moving faster now. We'll be moving faster. The next thing is that we want to do what? We want to create a pie chart. So for a pie chart as well, you know the drill. We'll plot our axis. So say plt dot figure, and then we'll pass in the fig size 7,4. Okay, then we'll say plt. But first of all, we need to group our data. Remember, else it will look disastrous in a pie chart. But let's see what I mean. Plt dot pie in this case, right? I want to do a pie chart, so we'll do plt dot pie. And then we can pass in, we want a count, so let's just get a count first. We have to do that regardless. So say station count, station cnt. I'll use cnt for count, and then that should be df, where's it, station dot count value. Why is it? Okay, value count, not count value. Okay, value count. Yep, that's value counts. And if you print this up here, just so you see what it looks like, station counts. Okay, because I've not executed it, so let's run that. So you can see what it looks like. Group data, the reset index. So we can have a good visual here. You see how this is floating. All right, so this is proper now. Okay, so right here, hold on, let me check something quickly. Okay, so this is what we have, and what else do we want to see? Now we can now pass this into our what's it called? Now for a pie chart, how does a pie chart work? A pie chart takes a label and values, right? A label, I mean a legend, and then values. This is what you'd have seen in Excel, Power BI, and all of that. So we'll pass in the count first, then we'll say labels, Then we'll pass in labels, label. So we'll pass in labels, and then we'll say labels will be station count. We can use the method, right, dot index. Is that correct? Yeah, that's correct. Why is it showing an error? Station count dot index, and we have the auto picked. All right. Then we can just say a 1.1. No, not like that. So I'll start with a percentage, and I do a 1.1 f. All right. So colors, we can pass in some colors directly. Colors as a list, of course. So let's say, how many stations do we have? We have about 4. Let's just use some random hexadecimal code. Let's use some random hexadecimal code. 4F81BD. Another one. Let's start with the hash first. C05040. Okay, let's just add the letter. Yep, should be 6, right? Yeah, that's 6. Another one is hashtag. It's add BBB 59. So let's pass in what else? Well, if this were live, I would have asked you for some color codes. So I think I've used this before. C4C060428. All right. So yeah, this is what we have, and this is really messing things up for me. Index is unknown. Are you sure about that? Are you really sure about that? Let's see. Okay, it's actually true. Could not convert string to float. So that is coming from okay, it came as a string. Let's see if I can do a type conversion here directly. Float. Yeah, everything is now being underlined. Nope, it's not gonna let me do that. Okay, I think I should wrap this way and wrap it. As a result of that, I want to convert to a float. All right. Labels, let's just change it to easy labels. Station labels will be station count dot station, and then this will be the value. So let's run that now. Still could not convert it to a string for the labels. Wait, no, let me read it. Could not convert string to float. Border station A. I think that's coming from here. Let me see. Let's check quickly. Code station dot let's just do dot info. Okay, so this is object and this is integer, so it's all good. It's all good. Object and integer. So we have it as station, and then that's count and station. Okay, so I think I'll just do a count here. Count, which is the value. All right, so the actual value is what has been yelling at me. So let me try my index again. Be sure that's working. Yep, that works. Of course, it's showing me it's been underlined, but we have what we want now. Ooh, the colors are weird. but it's okay. So this is what we have, and I think I'll use the the names instead. The names look better, and that is station. I don't know, is it capital station or small station now? Station. Okay, so we can see quality control 25.96%. I believe you should be familiar with this. We use it as well in our other stuff where we do column and then we do a figure like that there. So this is what we have for a pie chart. You can add the title and label. I will not be doing that. So do well to add a title, right? Majorly the title. The title is the only thing you want to add in this case. So let's jump quickly into scatter plot. Let's check a scatter plot out. So we want to check the cycle time by the temperature sensor, right? And remember, what is the cycle time? Let's go back to our data. Let's just print our data in here. df.ed. So you can see our cycle time, that's in minutes, and that's how long it takes to assemble a chassis, right? So we want to check if how long it takes is correlating with the sensor temperature. We want to see if the longer it takes, the higher the temperature. That's the idea. Because we've not discussed the correlation, I think in the statistics videos, I will be covering that. I just cover it. So let's just say, so we really want the points readable, right? We don't want 4050. We just we want it readable. So let's do something simple, right? We can just say sample. Okay, see, that's why I added those comments in there. So when we get there, we can remember that I'm supposed to do something particular in here. So I can say dot sample, and I'll pass in 100. Then random states. Make sure you use the same thing I use, 42. Then we can now pass this in our usual plt.figure. Oops. So just copy our plt figure straight away. Where is it? Why is it so far away? So plt.figure, and then plt.scatter. See, that's the only thing we change. We just keep changing the name of the variable. Then we can say our sample. Inside our sample, we want, okay, I've not executed this, but you should have our cycle time in minutes. Have our cycle time in minutes, and what else? We want to pass in the temperature. Are we still in the bracket? Okay, we're still in the bracket. So say sample again. Where is sample data coming from? We want to do a sensor temperature in C, and color still in the bracket. So we can just do it like this, break it open. But I've done that for others as well, though. It's not too late. So we can say color. This one is not showing color. Crimson. Crimson. Okay. And the transparency level, let's say alpha. let's say 0.5. Okay, so with this we can add labels, but of course let's print this out first to see what it looks like. Okay, we're getting an error. Temp o, that's key error saying temp o does not. Yep, that's temp, not temo. Okay, so you can see what this looks like, and this is a positive correlation because it's tilting towards the upward direction. And what does that mean? It means the longer it took for the what's it called to be assembled, the chassis to be assembled, the higher the temperature of the temperature of the sensor, right? So they are positively correlating. So just add the title, circle time versus sensor temperature, sensor temp, sensor temp in Celsius, capital Celsius, and then we'll do plt dot x label. X label is our circle time in minutes, and plt dot y label, plt dot y label, that's our temperature in degrees Celsius. I really want to put this degree there, but it's okay. In degrees Celsius. So let's run that again so we can have everything well titled. Good. All right, so that's that about the pie chart. So let's look at histogram. As usual. Let's copy our figure. Just paste it here. Now in this case we want to see the distribution of the cycle times. I want to see the distribution of the cycle times. So say plt dot hist, that's for histogram. Then we can say we'll still use our sample. So let's use our sample. Then for our sample now, okay, everything is now coming up. We have the circle time in minutes, and then we want to pass in our sample again. No, why am I using our sample? My mind is already going back to what we just finished. Okay, so we are using the assembly time. So we'll still be using cycle time, but of course from our major data frame. This just give us a sample of 100. So df, come on. Oh, let me just go and copy it. That's supposed to come up. I'll copy this, and then I'll paste. Okay, good. Then the next thing is we want to put in our beans. Okay, so say beans. Can pass in a number, right? Because this is a large what's it called? So I don't have to start passing the group myself. So I'll just say beans 30. It automatically does the grouping for me, and I can do a color. I can say color. Color should be, what color should we use? We have funny colors, but none is coming to my head. So I'll just say emerald. All right, and lastly, want to pass in the edge color. Let's see, the edge color will be black. Let's not overthink that. Black. And finally, transparency alpha. Okay, I think this can come like this. All right, So alpha will be equal to 0.7. Let's keep it that way. And of course, before you print yours, I would like you to have a title. Your title can be distribution of vehicle assembly speed, right? Distribution of vehicle assembly speed. Vehicle assembly speed is what we're looking at. So we're looking at distribution of vehicle assembly speed. Your X label can be minutes spent per vehicle chassis or minutes spent assembling vehicle chassis. And your Y label can be frequency, just frequency, or if you add any other thing to that. Okay, so let's see what this looks like for histogram. Okay, so we're getting an error. Emerald is not a color, it's not a valid color. Really? Did I spell it wrongly? Okay, so if that is not a valid color, let's say green. I know when it's already taking long, I could tell that it's there'll be an error. So what is this saying? Attribute error says rectangle dot set alpha not an argument. Alpha, okay. Though it displayed already, but that was incorrect. Okay, good. So we can see it showed us the distribution, and we can see what this looks like. So give it a title, take your time. Don't forget that the point is storytelling, so you interpret it. You want to tell that this is what this means. Your interpretation is very, very important. So let's say we want to do a heat map, right, which is just the correlation matrix of the values we have going on inside our data. So we can just say correlation matrix, say core matrix. Did I copy my figure size? I think I pasted something else after I copied something else. So Control C, as usual, Control V. This time we can do a 6 by 4. So for the correlation matrix, we want to say df, then we'll pass in a list of lists. I will have to start copying the list. Circle times, I want this. On circle times. We want the sensor temperature, we want the microdam time. So for me to make it easier, I can just up here do df.columns. Right, I can just copy the column names from there. Makes it easier. Okay, so sensor temperature. I think I'll copy with the quote itself. Control C, Control V, and then I'll copy this microdam times. So you see, just it makes it easier that, oops, I copied something else. Control C, Control V like that. All right, so this is what we want, and we have been able to, let me add a space there, and we've copied it. Then we have the dot correlation as a function or as a method that we can call on this particular data set. So that's what we want to plot out, right? So now we need a method, right, to be able to display the entries of our color grid. So, and it is plt dots im show. Where is it? Okay. Im show. And of course, Cbon makes it easier to work with what's it called? Heat map. Okay. So we'll pass in our correlation matrix. Say Cmap equals to cool warm or warm cool. Then we'll say interpolation. Interpolation is nearest. All right. You can now pass in the title. Let's just do that together in this time. plt.title. And the title in this case is IoT. IoT should be like this. IoT metric, not matrix, metric correlation matrix. Yeah, I don't think about that. So we want PLT. Now we want the PLT dot color bar, and that's to just add the spectrum scale, color scale to the sides, right? That's just what we want to do. So color bar, right? Okay, see it there. So color bar, and we want to have PLT dot xtick. So in this case, I'll just type in the code. Don't overthink it. Just type it out. Correlation matrix. Where's the variable? Is it okay? Correlation matrix dot columns. Columns. All right. And I'll come outside and say correlation matrix dot column. So I want the length to be the length of what's it called should be the same thing as the number of columns we have. So correlation matrix dot columns. We know what columns will give us, and I'll do for white tick. And that should be, did I spell columns correctly? I think I did. So just change this to white ticks. Okay. Let's print that. I hope I don't get an error. All right, I don't. So you can see this is the correlation matrix for what we have. So finally, let's quickly jump into the box plot. That should be the last one. Okay, so this is the last one. I think I'll just make matplotlib a separate video on its own, because I was hoping I would be able to cover everything as stretch, but I'll just break it down instead. So you have matplotlib, and maybe Seaborn and pyplot can now be on the same video. It depends on how long that takes anyway. So let's jump into it now. For the box plot, now let's understand the box plot. The box plots represent the 50%, the idea of IQR, right, of your data. That's from the 25th percentile to the 75th percentile. That means 25% of your data all the way to 75% of your data. Percentile, percentage, simple. So the line inside the box, which you will see, is the 50th percentile, which is the middle or the median of your data. And then we have whiskers, right? They extend to show the rest of the distribution range. And then we have the flyers or outliers, right? The dots outside these particular ranges, right? So let's plot it so that you can see what I'm talking about. So we want to probably group the data first to be able to do this. So say stations equals to df dot group by, and I think somehow I say group by now. Somehow I'm just thinking about it. I probably missed something in under handling data, right? When we're doing duplicates. So yeah, I think I missed something there, and that is unique because I'm just about to use it now. That's why I remembered, right? So unique, I use the unique method, and then we'll say data. Why are we getting unique? We just want to get the stations only, right? That's all. Let me print that for you to see what I mean. Stations, no, stations. So you can see it's just printing only the what's it called, the unique values. It's removed the duplicates completely. So we want data group. So now you know about unique. So we'll now say, let's say data group or groups or whatever. Now let's pass this in as square brackets. Then I want a condition where I say, because I want to do a list a list comprehension, right? That's why I started with the square brackets. A list comprehension is just, instead of writing too many long, I said too many long of code, too many codes. A list comprehension, if I think we covered that already in the data structure video. Do well to check it out. I'll probably leave a link to it in the description below. We did dictionary comprehension as well. Okay, so that's where we said we can get the square of a data. So we can say x, for example, square, right? So then we can say for x, in range of something. So this just loops over the data and gets us the square of individual numbers, right? So that's what we're doing. So here we want to say for the station df, then df station. Don't get confused, don't worry, I'll split it out so that the square brackets doesn't confuse you. I think station is in capital. Station coming. So df 1 2 3, okay, let's say equals to st, and next one we'll say cycle times. Whereas I think I can just copy that quickly from here. Okay, copy that from here. Okay, cycle times in minutes. So then we say, okay, let me close the last bracket. That's why that's yelling at me. So we'll now say for, now based on this condition, for st in station, or we can just use the full word stations anyway, so that will make sense. For station in stations, so let's change this to station. We can do for station in stations, right, where df is equal to station. Let's see the group type, data group. So you see what that looks like. You should have a picture of what we'll be getting anyway. Okay, so you can see for individual groups, that is what we get. All right, so let me take this out. I think this should be like this. So we have been able to do this. The next thing we want to do now is our figure as usual. I'm just going to copy that. Where do we have it? Okay, Ctrl C. Do not forget that to save any of these images, you have to do plt.savefig. Then you pass in the name and pass that, and then you can pass in the DPI, two key things, and then you're good to go. It saves your data directly. So fixed size, let's do it by 5. It's by 5. And then we want to do plt.boxplot. Okay, so right there. So pass in the data groups. Then we'll pass in, I think so far we've been doing this separately. So let's cut it out as well. Paste that in here. We've already executed it in this cell, so I don't need to run it right here again. But if you have not, so just make sure you run this first before you come here to run it. So we can do data groups, and then we'll say labels. Is it label? It should be labels. It should be labels. Let me just leave it that way. Labels, stations. All right, so that will be stations. Then you can pass in the title. By the way, we have not really explored some other things in the title. So let's do the title together this time as well. So I can just say vehicle assembly cycle time dist distribution. by station. It's good if the title is long and descriptive. It's better than short and not making sense, by the way. So we can pass in a font size. So these are some of the things I want us to look at. Font size. Okay, font size, we can say it's 12 pixel. Then font weight equals to bold. You can see all of them in the documentation of what's it called, this particular uh, guy itself. I think this should be in quotes. Okay, label is shouting at me, but it should be label. I strongly believe it should be label. Yeah, it is label. So you can see for every group we have the box plot, and we can tell where we have the outliers. You can see them. Those are the ones jumping up. This is 50% of our data, 50%, 50%. You can see we have for individual stations that way. So that's why we grouped the stations separately. So for every station, right, we want to get the cycle time, and it's a list comprehension, like I said. We're passing it into a list comprehension. So it says labels parameter has been renamed to tick labels. Okay, so it is tick labels. So sometimes it's just good to read the warning or whatever it is that you're seeing there. So tick labels. Now my station is now throwing an error. Let's see. Vehicle assembly time. Okay, no more error. I'm not sure why this is just shouting on its own. So now we have been able to get our distribution, and yes, so far this is nice. And yeah, we've come a very long way. We have seen how, I believe, with the repetition of examples, you now have a good hang of how to use matplotlib. So let's now see the axis method, or the subplot version of it, which is more of an object-oriented operation. Okay, I will not be speaking too many English in this regard. What I'll just tell you is that so far PLT lets us plot a single chart. But what if we want to do a multiple chart on our data? Okay, so let's see what that would look like. We'll say fig, then ax. You know what this is already. This is more of a this is a the structuring, right? This is the structuring. So we'll pass in fixed size, in there. As usual, we'll pass in our tuple 8 by 4, and then from there we can start plotting. So we'll just do ax.plot. Now the beauty of this is that we can pass in this thing should get out. So we can pass in the subplot value itself. So what's the idea of a subplot value? So for a subplot, we can say after the fixed size, we can pass in the number of rows first, as usual, n rows and n columns. So if I say 2 by 2, for example, I can type in n rows like this to be 2, and n columns like this to be, I just want to make that clarification so you have a good hang of what we're doing. 2 by 3. Now what this will mean is that it will have 2 row space and 3 columns. That means you can plot 6 charts using this axis. By default, you don't have to put n rows, n column. I can just put 2 by 3. Okay, so it means it gives us the opportunity to plot in 6 charts in a single view. So we can see it as 1 year, 1 year, 1 year, 1 year, 1 year, 1 year. So you can see the more flexibility. You can see more flexibility that we get with the object-oriented method, which is using the subplot, right? So, and how do you assess it, right? How do you assess it if, let's say, we do something like 2 by 2 or 2 by 1? If we do a 2 by 1, let's start with something simple. That's 2 rows, 1 column. That's on top of each other, vertical. So it will be axis, for example, 0, then dot, whatever kind of chart you want to use, dot bar, dot plot. Now this will be at the top, right? Then if we want it to be at the bottom, we say axis.1, right? Position. So if it is a 2 by 2, if it's a 2 by 2, you can guess that you start passing what? Two kind of variables. So for example, 0, comma 0. First row, first column, right? First row, first column. Now, I think I'll just put this somewhere for you. We'll not be using it, but I want you to have a good understanding of it, right? Okay, so let's say hashtag 2 rows by 1 column. Axplots 0 dot, let me say chart type. So notice that chart type, this is just a syntax that I'm giving you, then you pass in your whatever. So this will be first top row, since it's just one and it's just a single column. This will be bottom row. Okay, bottom row. So let me copy this again and do another version. So let's say I can just remove this, like I said, 2 by 3 or 2 by 2 to make it faster. 2 row, 2 column. So ax 0, 0 dot ax 0, 1. Though we can also destructure this into axis 1, axis 2 as we please. So 0, 1 dot, then we have axis 1, 0, and last one will be 1, 1, and axis as well 1, 1. Okay, so just say the chart type, Control C, just do a cursor, a multi-cursor option, Control V. All right, and then we'll say hashtag. Okay, I think I have to type one by one now. Row 1, column 1. This one will be row 1, column 2. Row 2, column 1, and row 2, column 2. All right, so this is what you have. Oh, okay, that had dots in it. Okay, so we have taken that out. So this is the idea of subplots, right? So let's just move on fast now that you have a good hang of it. Okay, so let's say we want to I'll take out all of this. I'm not passing. I just want a single blank canvas like what we did before. So let's say we want a just like something like what we did before. So just passing ax.plot. I might not complete it. I'll just leave that for you to finish up. The first thing we used was the timestamp, and the next thing we used was, I think we used the daily. We grouped somehow at some point, right? Let's check that. I just want to give you the idea of the difference. That's the major difference I've set out. So just a few differences I will highlight, and then you finish up. You recreate the rest of this chart with the same thing. Okay, daily, right? We did the daily. We grouped it. I want to do the line chart first. Maybe I'll do the line and the bar, then you do the rest. So changes to daily. Daily DF, and daily DF again in square brackets, and then I want to pass in the sensor temperature, and finally I want to pass in a color. I think we used orange earlier. I'll just use the same orange. It should be good. All right. So you can see that we have created exactly what we had earlier. And we can of course pass in marker, just as you've probably thought. Marker equals to O. Okay. So we can pass in marker as asterisk. Let's pass in marker as asterisk this time. So you can see I've passed in the marker as asterisk. So we don't use O. Now, what are the customization like? In this case, we don't say ax or ax, axis, ax.title. We say set title. Set title. So in this case, we can say daily avg sensor temp in degree. Okay. So for y label and x label, we're just saying ax dot set. So we just have a prefix of set, x label, then we'll say date, then ax dot set label, set y label, and that will be temperature. I'm just say temp, keep it short. Okay, temp. Of course, we can set our grid to be true. All our grid settings. Let's copy our grid settings from the very first one. Okay. Okay, so this is it. So come back here and then we'll do grid. So of course we just change this to ax, and this will now be, instead of x tick, right, we'll say tick parameters. So we'll say tick or ticks. Is it tick? I think it should be singular. Ooh, okay, just hold on. So tick underscore params, right? Should come here, underscore parameters. So we now have to pass in the axis we want to, in that one we say x tick. We pass in x tick directly, but here we pass in the axis inside the square, I said the square bracket, inside the string. So say axis is this, and then, so basically this is all we have done before, and you can now recreate them. You can pass in font size into the title. You can do as much customization as you want, and if you run that, so you can see we get the same feel, everything looking very nice, just like before. So you can do the subplots, and then do your bar chart, same thing we did, do your line chart. So as a challenge, I want you to do everything. Like I said, everything we did before is the same. You just change it to ax, and then you remember your prefix for set. Okay, you remember your prefix for set. Would there be any difference at any point? Not necessarily. Not necessarily. Maybe just the box plots, the heat map. So let's do the box plot together. I think the box plot might have. So let's do the box plot together. The rest you do yourself. I have to copy a lot of things. I don't want to retype all of them. Ctrl C. Let's paste them twice. Okay. So for the heat map, now for the heat map we have to use Cbon, right? So I'll just we have to use SNS. So I'll take that out completely, or undo. I'll just use it for the histogram instead. So I'll say box plots. I'll just put box in front of it. So box plots, and then we'll say our data group. Let me take out everything in here. I'll pass our data groups. and then we want to pass in our label. Should be labels. Not really different anyway. I don't think it will be different. I know that once I type it out, it will come out of my head. It's somewhere in there. So thinking about it sometimes is not coming through. So okay. So I can pass in other variables. Let me push this down. I can pass in other parameters and arguments such as come back here. I can pass in patch artist. I can set that to true. What else can I pass in? Okay, so I can come here and say box props. Box props. So let's bring this out. So I'll gradually see what we want to see. I'll just take all of this out. We don't need that. You can do the customization for that later. So you can see that so far we have what we want and not so much difference. Let's pass in some more variables. Let's say box props. Is it box prop? Yeah, box prop properties. So we can say we'll pass it as a dictionary, and then we can say face color, light gray. And say color dark blue, yellow, red, purple, green. And we'll just keep passing like that. Then we can say the medium properties. So you can see we have more flexibility. So we are passing different properties for the stuff, the plots, right, individually. So you can say red, line width, or what else should we pass? Line width 2. What else can we pass in? Filer props. Or filler props, I mean. Not filler props, fly props. That's for the outliers majorly. We'll pass in dictionary as well. So we can say marker equals to O, marker face color equal to crimson, and we can pass in a marker size if we want. Marker size 3. Okay, what else can we pass in? Let's close our full brackets. That's from the guy from the top. Okay, no, it's closed. Is it? No, it's not. This closes this. This closes this. Okay. Oh, we accidentally closed it already. So that should be at the end here. So you can see the color code. Of the color code, I was able to tell what I'm doing right or wrong. You can see I'm able to change the feel of everything. So yes, with this, I can say we have come to the end of matplotlib. I really hope you learned a lot of things and you're more comfortable using matplotlib. It has now become a zero intimidation library for you to use. And if you like, or if the video is explanatory, you like the video, just give it a thumbs up. It costs you nothing, literally. If you're not a subscriber, you'll be missing out on more things to come. And when I say more things to come, not just on tutorials alone, other things are coming, but I will not let the bag out of the cat. Yeah, you know what I said. So yeah, do it to subscribe and make sure you turn on the notification button to all notification. Why is that important? So that when there's a new video, YouTube notifies you that there is a new video, so you don't miss out on any particular video from this channel. If you know someone who this can help, do well to share the video with them, or you share the link to the channel with them, so they can join as well, learn as well, and become better as well. Okay, all right, for this and more, I'll see you in the next video where we'll be looking at Seaborn. And till then, keep practicing, keep practicing, keep practicing. Do not forget that you have some exercises to do, right? The exercises such as recreating all the charts using the fig and axis. And I think I also mentioned some in the beginning at some point. Yeah, do well to explore all of them. Yeah, like for example, completing the title, adding the axis, and the rest of that. So do well to carry out all of them. They are important for your growth. I can decide to leave it out, but you won't improve or get better that way. Watching me write it alone will not really help you so far. So at some point you have to like pause the video, try to do something on your own, and that's why I give all of these exercises to help you get better. So yes, for this and more, if you like the video, leave a thumbs up, subscribe to the channel, turn on notification. For this and more, I'll see you in the next video. Till then, keep practicing, keep practicing, keep practicing.